Hello, grade 7. This is Mrs. Lopez and lesson 11, ratios of fractions and their unit rates. Notice that we are almost done actually with module 1. We are right now in topic C, and the topic C will cover lessons 11, 12, 13. We are going to skip 14 and get straight to the 15. So 11, 12, 13, 15. And that will be all. We are starting with lesson 11. And the only difference in topic C from topic B is that we are working with all sorts of integers, fractions, and decimals. We are going to mix them all up together. And you will need your knowledge of how to divide fractions and mixed numbers, how to divide decimals, how to multiply fractions and mixed numbers. And so if you need that extra practice, YouTube has many videos on how to do it. And I will also try to find a good one and post it on Google Classroom. So let's go ahead and start. In example 1, who is faster? So during their last workout, Nellie ran 2 1/4 miles in 15 minutes, and Jagan ran 3 3/4 miles in 25 minutes. Nellie says she's faster than Jagan. Who is faster? We need to organize our thinking in a table. I actually don't like the table here, so I'm going to find the unit rate better. I want to see if the unit rate is the same or different, and how it is different, if it is different. So I want to look for the rate of miles per minute. So I'm going to look for miles per minute. And let's look Nellie's first. And Jagan's next. So Nellie ran 2 1/4 miles in 15 minutes. Notice how I'm writing this fraction or a division problem. I'm dividing 2 1/4 by 15, but instead of division sign that you are very used to, I'm going to write all the division now using fraction bar right here. And to divide mixed number, I need to make sure that I change it into improper fraction. So that will look like this. 4 times 2 plus 1 is 9/4 over 15. Look at how complex it looks like. When I divide fractions, instead of dividing fractions, I always need to multiply by the reciprocal. So I'm going to multiply both of these by their reciprocal to get rid of that 15 at the bottom so it doesn't look that complicated. The reciprocal of 15 is 1/15. This way I will make one whole and I will get rid of that. I'm going to do the same thing with my numerator. Multiply by 1/15. Okay? So this 15 and 15, they get simplified, it's done, we don't have to worry about it. All is left is this part. I'm multiplying 9/4 by 1/15. I can simplify 9 and 15 by 3. I can divide both of them by 3. 15 divided by 3 is 5, and 9 divided by 3 is 3. So I will get 3, and I have 4 in the denominator multiplied by 5 in the denominator, and that is 20th. 3/20 is my answer. 3/20 miles per minute. That is for Nellie. Now let's look at Jagan's rate. Okay, so Jagan ran 3 3/4 miles in 25 minutes. So I'm going to divide 3 3/4 by 25. I'm going to change my mixed number into an improper fraction. 4 times 3 is 12 plus 3 is 15/4, and I'm dividing that by 25. And if you want to put it over 1, you can. You don't have to if you understand how the fraction works. And instead of dividing, I'm going to multiply by the reciprocal and getting rid of that complex fraction that I see here. I'm going to multiply by 1 over 25. both of them. 1 over 25. When I simplify 25 and 25, it becomes 1, so I don't have to worry about this part. This part is the one I'm going to be focused on. I can simplify 15 and 25 by 5. 25 divided by 5 is 5, and 15 divided by 5 is 3. What I have left here is 3, and 4 times 5 is 20. 3/20 miles per minute. So I'm looking at this unit rate, and I'm thinking, who is faster? Since the unit rate is the same, it means no one is. It's a tie. They are riding at the same rate. They're going to make it to the finish if they continue riding at the same rate together. So that means that no one is faster. Their rates are the same. Their rates are the same. Okay, so that is pretty much it. So you notice how I still find the unit rate. I'm just dealing with harder numbers written as mixed numbers and fractions. And this division does not look like division you studied in grade 6. That's what we are going to be focused on. Let's go ahead and move on to the next page. Is Meredith correct? A turtle walks 7/8 of a mile in 50 minutes. What is the unit rate when the turtle speed is expressed in miles per hour? Now here we have another new thing that we haven't seen before, is we have minutes in our problem, in our situation, but the question is asking for miles per hour. And this is something to be focused on and pay very close attention to when you are solving problems. Sometimes they can ask you for different units. To find the turtle's unit rate, Meredith wrote the following complex fraction. She wrote 7/8 over 5/6. Where did the 5/6 come from? How was it obtained? Well, think about it for a second and come back here. Okay, so we want to have a rate of miles per hour, correct? So we have 7/8 of a mile, and we want to have 50 out of how many minutes in an hour? 60 minutes. And if I simplify 50/60th by dividing by 10, I will get 5/6. That's where it's coming from. 50 minutes is 5/6 of an hour. 50 out of 60 simplified. Determine the unit rate when the turtle's speed is expressed in miles per hour. So now we're actually going to find the unit rate. So 7/8 divide by 5/6. Again, complex fraction. To get rid of that complex fraction, I'm going to multiply by the reciprocal. 7/8 multiplied by the reciprocal of 5/6. So reciprocal of 5/6 is 6/5. And I'm going to multiply both parts of my complex fraction by it. 5 and 5 in the denominator get simplified. 6 and 6 get simplified. I got rid of that fraction. I don't need it. All I have left is the numerator that is looking like this. Is there anything I can simplify? I can simplify 6 and 8 dividing by 2. 6 divided by 2 is 3. 8 divided by 2 is 4. So all I need now is to multiply the numerators and the denominators. 7 times 3 is 21, and 4 times 5 is 20. 20 over 21 is an improper fraction. We want to make it a proper fraction or a mixed number. 20 goes into 21 once, and I have 1/20 remaining. So that means that the turtle can walk with the speed of 1 1/20 miles per hour. You can decide whether it's fast or whether it's slow. Okay, let's look at the exercises. For Colton's birthday, his mother is making cupcakes for his 12 friends at daycare. We want to make, the recipe makes 2 1/2 dozen cupcakes and calls for 3 1/3 cups of flour. Does she have enough flour for each friend to get a cupcake? Well, first of all, we need to note, and there was a typo in the packet, that she only has 1 cup of flour. And we also need to know that it's not cookies, it's cupcakes. Otherwise, people can get confused. All right, so since she has 1 cup of flour, we want to find the unit rate. We are going to find out the rate of cupcakes per cups of flour. Cupcakes, number of cupcakes per cup of flour. Why I chose this rate is because I already will have 1 cup of flour. That's exactly how much I have. And so if I find the number of cupcakes, I will be able to find out whether she will have enough flour or not enough. So let's take a look here. Since we want cupcakes per cup of flour, then we are going to divide cupcakes by the cups of flour. So let's change our dozen cupcakes into the number of cupcakes. 2 dozen is 24. All right, 1 dozen is 12, 2 dozen is 24. What is half a dozen? Half a dozen is 6 because 1 dozen is 12, right? So 24 plus 6 is 30 cupcakes. So I'm going to write it down here probably. 2 1/2 dozen equals 30 cupcakes. Okay, so we are going to divide those cupcakes by the cups of flour that we have. So 30 we are dividing by 3 1/3. All the mixed numbers need to be changed into improper fractions, no matter where they are in the numerator or the denominator. So it's going to be 30 divided by 10/3. To get rid of the complex fraction, I'm going to multiply both parts of my fraction by the reciprocal. Times 3/10 times 3/10. 3 and 3 get simplified, 10 and 10 get simplified. I got rid of the complex fraction. So now I have 30 over 1 times 3 over 10. I can simplify 30 and 10 by 10. And I will have 3 times 3, and that is 9. So 9 cupcakes per 1 cup of flour. Since there are 12 friends in the daycare, and she can only make 9 cupcakes with 1 cup of flour, will she be able to make enough cupcakes for all the friends? No, she will not be able to, unfortunately. She can only make 9 cupcakes with that 1 cup. All right, let's look at the next one. The local bakery uses 1 7/75 cups of flour in each batch of cookies. The bakery used 5 25 cups of flour this morning. How many batches of cookies did the bakery make? So to find that out, let's think about our unit rate or constant of proportionality. We know that 1 7/75 cups is for 1 batch. So actually, that is our unit rate, 1 7/75, right? We also know that the cups are over the batch. That makes the cups of flour a Y and batch an X. y is the cups, batch is our x. We want to put it into our formula. Since this is our k, constant of proportionality, 1 and 75 hundredths, and we know our y and we know our x, we have cups equals 1 and 75 b for batch. Now we want to see how many batches of cookies did the bakery bake if they used 5 and 25 hundredths cups of flour. So we know this cups of flour number. It's 5 and 25 hundredths equals 1 and 75 hundredths b. To find out that b, what is 1 and 75 hundredths multiplied by to get this number, we are going to divide 5 and 25 hundredths by 1 and 75 hundredths. So we can set it up this way. 5 and 25 hundredths divided by 1 and 75 hundredths. Since we are dividing decimals, we know that we cannot divide by a decimal. We need to multiply this number by 100 to get rid of the decimal. Since I multiplied this by 100 by using equivalent ratios, I know that to make it equivalent, I also need to multiply 5 and 25 hundredths by 100 and move my decimal. So now I need to divide 175 into 525. The number is 3. So that means that the answer is 3 batches of cookies or we can write the bakery made 3 batches of cookies. The bakery made 3 batches of cookies. That's our answer. If there are 5 dozen cookies in each batch, how many cookies did the bakery make? So 5 dozen, let's see how much that is. Dozen is 12. 5 times 12 is 60. Right? If there is 60 cookies in each batch and they made 3 batches, so we will have to multiply 60 by 3 batches and we are going to get 180 cookies. 180 cookies. Okay? We are on the third problem. Thelma is shopping and can't decide which pack of granola bars to buy. The 12 pack of granola bars costs $2.99 and the 18 pack of granola bars costs $4.79. Which is a better buy? We already solved these types of problems, but right now we want to really try not to use calculators for it and really find out for ourselves. So we can look for the unit rate, which is dollars per pack, or dollars per granola bar rather, and we are going to divide dollars by the 12 and 18, right? So we will have $2.99. We are going to divide by 12 and we will have $4.79 divided by 18. I don't have a decimal to divide by, so I'm just going to put my decimal right up in both places. 12 cannot go into 2, so I'm going to put a 0. 12 can go into 29 2 times, and that is 24. And I will subtract, getting 5, and bring down the 9. 12 can go into 59 4 times. 4 times 12 is 48. I will subtract, and I will get 11. Now I can add a 0, because after the decimal, 0 don't really matter. We have 110. 110 divided by 12 is a 9, and it's 108. I can continue dividing, but I don't have to because I want to find the number of dollars per pack. That means I need to round to the nearest hundredths here to be able to find out the number of cents. So I'm looking at the hundredths place, the last cent that I can get, and I'm looking at the number on the right, and that's 5 or above. If 5 or above, we are rounding up that 4 into the 5. So that will be about 25 cents per granola bar. Now let's look at my other division here. So 4 and 79 cents, I'm dividing by 18. I already moved my decimal. 18 does not go into 4, so I'll put 0 over 4. Then let me just turn the light on here. Okay, sorry about that. So we have 47 divided by 18. 47 divided by 18 is 2. 2 times 18 is 36. I'm subtracting and I'm getting 11. Bringing down the 9, 18 goes into 119 6 times. Put 6 over 9. That makes 108. I subtract and I get 11 again. Now I can put the 0 and bring it down. And 18 goes into 110. Also 6 times, because that will give me 108. Again, I can continue dividing, but I don't have to because I need to round to the nearest cent. The cents place is the hundredths place, so it's a 6. Next number is a 6. So it's 5 or above. It means I have to add that 1 to the 6, and that is going to be 27 cents per bar. So which one is a better buy? The one that is 25 cents per bar, which is the pack of 12 for $2.99. The pack of 12 is a better buy. A pack of 12 is a better buy. Okay, so that is our lesson 11. Do your homework. There are 3 problems in that homework, and I will see you in class, and we will get to the next lesson later. Bye.